Hi students, how are you? This is the time to learn the concept of physics. As you know, physics is one of the most important subject for a competitive examination like NEET, JEE, main as well as advanced. Through this video, I will going to explain how one can understand the concepts of physics in detail. Therefore, I will start one of the main branch of the physics, that is mechanics 1 for NEET, JEE, main and advanced. Here you are now listening only voice. Okay, I am your favorite teacher, AP sir. Welcome to my channel. Physics NEET, JEE, MCQs by AP sir. In this video, you will understand the concept of physics. Let me start the first chapter, dimensions and measurements. Here in this video you will learn in detail introduction part, physical quantity, types of physical quantity, fundamental and derived quantities, fundamental and derived units, SI prefix, as well as the concept, application, exercise. So these are the different concepts what you will learn. In case of that, the concept, application, exercise. Let us move through one by one. Here, what exactly that physics indicates? See here, you can easily understand the concept of physics in introductory part. Why we should learn the physics, or what is the meaning of the physics? So you should remember, like all other sciences, physics is based on experimental observations and quantitative measurements. What about experimental observations as well as quantitative measurements? Let us learn one by one in detail in this video. The main objectives of physics are to identify a limited number of fundamental laws that govern natural phenomena and use them to develop theories that can predict the results of future experiments. So what we should know, why we should learn the physics? If we wanted to do any experiments in future, we should predict that in external world. The fundamental laws used in developing theories are expressed in the language of mathematics. The tool that provides a bridge between the theory and the experiment is a mathematical tool. Okay, now let us try to understand what about the physical quantity. Physical quantities are nothing but a quantity which can be measured and by which various physical happenings can be explained and expressed in the form of laws is called the physical quantity. Any quantities one can measure. In general, in simplified manner, the measurable physical quantities or any quantities you can measure by using any one of the instruments, such quantities are said to be physical quantities. So for example, the length, the mass, the time, the force, all these are measurable physical quantities. I told that it may be a length, you can measure the length, or it can be a force, you can measure the force, it can be a mass, you can measure the mass. So all these are measurable physical quantities. So length one can measure by using a centimeter scale or meter scale, force one can measure, or mass one can measure by using weighing scale. Any quantities, if you can measure, such physical quantities are called measurable physical quantities. Measurable physical quantities. So what you are getting? Measurement is necessary to determine the magnitude of a physical quantity. So why you should measure? It is used, measurement is necessary to determine the magnitude of a physical quantity, or to compare two similar physical quantities, and to prove physical laws or equations. So all these are things you should require. What you should do if you wanted to express the magnitude of physical quantity, or to compare two physical quantities, or to prove physical laws or equations. So these are the things why we should measure the physical quantities. So a physical quantity is represented completely by a magnitude and unit. So what you can think here, for example, the physical quantity can be represented by a magnitude and unit. Let us try to understand what is the meaning of magnitude and what is the meaning of unit. So here, very important factor, a physical quantity can be represented by a magnitude and unit. Unit. What is magnitude or what is the unit? For example, 10 meters, a length which is 10 times the unit of length. If you take, for example, length is expressed in meter. If you are calling length of any material is 10 meter, that indicates that 1 meter repeats 10 times. 1 meter repeats 10 times. Similarly, if you say what is mass? Mass of a body is 10 kg. That indicates that 1 kg repeats 10 times. 1 kg repeats 10 times. 10 times. Same way, if you take 27 degrees Celsius is the unit of temperature. That indicates that 1 degree Celsius repeats 27 times. That is nothing but repetitions. So you should remember why we should know the physical quantities, or what are the uses of that. So you should remember here, already I told that what is the unit of that, why the magnitude as well as unit required. So you should remember here. Thus, in expressing a physical quantity, we choose a unit and then find that how many times that unit is contained in a physical quantity. So I already told that how many times a unit repeated in that physical quantity. So you can write physical quantity Q is equal to. So you can write here immediately physical quantity Q is equal to. If you write what is the physical quantity Q? See, physical quantity Q is equal to physical quantity Q is equal to is nothing but magnitude into unit. Magnitude into unit. Physical quantity Q is equal to magnitude into unit. That indicates that Q is equal to N into U. Q is equal to N into U. What is N? N represents the numerical value and U represents the unit. You can write N represents numerical value. Numerical value is nothing but one number, and U represents its unit. So you can write a physical quantity one can represent Q is equal to N into U. So these are the things you should remember here. Now let us move towards what about that physical quantity. Already told that here. For example, so but their product Q is equal to N into U. The product of NU remains constant. That indicates that N is inversely proportional to U. N is inversely proportional to U, or you can write N1 U1 is equal to N2 U2. N1 U1 is equal to N2 U2. I think it is clear. You got it, no? So let us try to understand. That is, the magnitude of a physical quantity and units are inversely proportional to each other. That means that larger the unit, smaller will be the magnitude. So larger the unit, smaller will be the magnitude. So these are nothing but the physical quantity relation. So you should remember the product of N and U remains constant as N and U vary individually. That is inverse relation. As N increases, U decreases. Okay. Next, let us move towards the next concept, that is types of physical quantity. Types of physical quantity. Now let us try to understand the types of physical quantities. Here, the first type of physical quantity is the ratio. And ratio is only numerical value. That is number. Second physical quantity is a scalar, and next physical quantity is a vector. Let us try to understand one by one in detail. What is actually ratio? Ratio is when a physical quantity is ratio of two similar quantities. It has no unit. For example, when a physical quantity is the ratio of similar quantities, then you will get the unitless physical quantity. For example, if you understand the relative density. What is the meaning of relative density? If you take a physical quantity which is relative density is nothing but density of object divided by density of water. Here actually what you are getting, density of object by density of water. Density of object, density divided by density, its unit will going to cancel. You know that density is nothing but mass by volume. You are getting it is kg per meter cube. Here also kg per meter cube. Both will going to cancel. You are getting only a number. You got it, no? That is nothing but a ratio. You are getting a ratio of two identical physical quantities are unitless physical quantities. Unitless physical quantities. Same way, there are so many other physical quantities you are getting. That is nothing but one, refractive index as well as a strain. What is refractive index? Refractive index, RI. Refractive index is given by the velocity of light in air divided by velocity of light in medium. If you take small v, velocity of light in air divided by velocity of light in medium, since it is the ratio of velocities, it is only a numerical value. Same way, if you take a strain, what is strain? Strain is given by change in dimension divided by original dimension. Dimension may be length or area or volume. It is also unitless physical quantity. But there is one physical quantity you are getting, that is angle. Angle is also the ratio of identical physical quantity, but it is having a unit, that is either radian or steradian. So it is nothing but what you are getting, arc length divided by radius. Even though angle is the ratio of identical physical quantity, it is having unit, it is exceptional case. So the ratio is nothing but a numerical value only. For example, relative density, it is the density ratio of densities, refractive index, ratio of velocities, strain, ratio of length, angle, arc length by radius. But angle is the one of the special case here. Even though it is the ratio of identical physical quantity, it is having unit. Okay, so what happens actually? Angle is an exceptional physical quantity which, though is ratio of two similar physical quantities, where angle is nothing but arc by radius, but it is having unit. What we will say, will require a unit, degrees or radian, to specify it along with the numerical value. So these are nothing but first type of physical quantity. Now let us come towards the scalar. Already I written here, scalar having only magnitude. What is actually scalar? These quantities do not have any direction. No direction at all. No direction. For example, if you take the physical quantity like length, time, work, energy, etc. If you take the length, if you take the time, if you take the other physical quantities such as temperature, density of a substance, all are scalars irrespective of the direction of measurement. They having only magnitude. So the magnitude of a physical quantity can be negative. In that case, negative sign indicates that numerical value of the quantity under consideration is negative. It does not specify the direction. Imagine if you get some negative values in case of the scalars, negative value will not give the idea of direction in case of the scalars. Then you should remember, scalar quantities can be added or subtracted with the help of following ordinary law of addition or subtraction. So these are nothing but normal algebra you can use to solve the problems related to scalars. Normal addition, normal subtraction you can make. Now let us move towards the next type of physical quantity. It is a vector. It is a vector having both magnitude and direction. So what you are getting here, for example, if you take, in case of vectors, it is having both magnitude as well as direction. So if you take the examples such as displacement, velocity, acceleration, force, etc. If you take, what is vector actually? Here it may be displacement having direction. If you take velocity, same way force, all these are vectors. We will specify vectors in terms of it is vector S or vector V or vector F, like that. All these are physical quantities having both magnitude as well as direction. So what you can take here, vector physical quantities can be added or subtracted according to the vector law of addition. These laws are different from the law of ordinary addition. So what we are taking, you can solve the problems related to vectors by using vector algebra, not by normal algebra. So these are the different types of physical quantities, the ratio or scalars or vectors. These are, ratio means the ratio of identical physical quantities are unitless, they having only numbers. Scalars having only magnitude, and vectors having magnitude and as well as direction. And scalars, you can, to solve the problems related to scalars, you can use the concept of normal algebra. To solve the problems related to vectors, you should use the vector algebra. So these are the types of physical quantities what we should learn.